Hello, welcome to IT Expert YouTube video series. Today we are going to talk about cloud security interview questions. What is cloud computing? Cloud computing is the on-demand availability of computing resources as services over the internet. It eliminates the need for enterprises to procure, configure, or manage resources themselves, and they only pay for what they use. There are three types of cloud computing service models: infrastructure as a service that offers compute and storage services, platform as a service that offers a develop and deploy environment to build cloud apps, and software as a service that delivers apps as services. Why should you use cloud computing? Cost. Cost reduces company costs because you aren't responsible for purchasing hardware and software that needs to be set up and run on site. Speed. Speed. Cloud computing is a service provided on demand. Large amounts of resources and data can be provided instantly. This means that with just a few moments, you can access almost any file you have saved in your cloud. Security. Most cloud providers offer policies, technologies, and other options that help to increase your company's data security. Productivity. Cloud computing also helps improve productivity since it doesn't require the same amount of hardware setup that other data centers need. Reliability. With cloud, you receive more reliability since it allows you to easily back up data, set contingencies for data recovery, and streamlines business continuity. What are the general characteristics of cloud computing? On-demand computing and self-service provisioning. Cloud computing's characteristic of self-service provisioning goes hand in hand with on-demand computing capabilities. Instead of waiting for new servers to be delivered to a private data center, developers can select the resources and tools they need and build right away. Resource pooling. Public cloud providers rely on multi-tenant architectures to accommodate more users at the same time. Customers' workloads are abstracted from the hardware and underlying software, which serve multiple customers on the same host. Cloud providers increasingly rely on custom hardware and abstraction layers to improve security and speed users' access to resources. Scalability and rapid elasticity. Resource pooling enables scalability for cloud providers and users because compute, storage, networking, and other assets can be added or removed as needed. This helps enterprise IT teams optimize their cloud-hosted workloads and avoid end-user bottlenecks. Clouds can scale vertically or horizontally, and service providers offer automation software to handle dynamic scaling for users. While scalability tends to describe longer-term cloud infrastructure plans, rapid elasticity is more of a short-term characteristic. When demand unexpectedly surges, properly configured cloud applications and services instantly and automatically add resources to handle the load. When the demand abates, services return to original resource levels. Pay-per-use pricing. This cloud computing characteristic shifts IT spending from CapEx to OpEx, as providers offer per-second billing. IT teams must be careful since their resource needs likely aren't static. Measured service. Measuring service usage is useful for both a cloud provider and its customers. The provider and the customer monitor and report on the use of resources and services, such as VMs, storage, processing, and bandwidth. That data is used to calculate the customer's consumption of cloud resources, and feeds into the pay-per-use model. The cloud provider, meanwhile, can better understand how customers utilize its resources and potentially improve the infrastructure and services offered. Platforms for using large-scale cloud computing. Apache Hadoop. 4 modules comprise the primary Hadoop framework and work collectively to form the Hadoop ecosystem. Hadoop Distributed File System, HDFS, yet another resource negotiator, YARN, MapReduce, Hadoop Common. MapReduce is a programming paradigm that enables massive scalability across hundreds or thousands of servers in a Hadoop cluster. As the processing component, MapReduce is the heart of Apache Hadoop. What is the main objective of cybersecurity? The goal of cybersecurity is to prevent or minimize damage to or destruction of computer networks, applications, devices, and data. To be successful, a cybersecurity plan must constantly change to keep up with the altering techniques and technology utilized by hackers. Cybersecurity professionals should always be looking for new ways to protect their organization's information systems. There are two main types of objectives in cybersecurity: technical and non-technical. Technical objectives include things like ensuring that all system software is up to date, that security patches are installed on all computers, that workstations are protected by security policies, and so forth. Technical objectives are important because they help ensure that computers remain secure even if someone manages to get physical access to them. For example, Keeping workstations locked away in a safe place with only authorized users able to log in would not be sufficient protection against a malicious employee, but it would be effective in preventing random hackers from accessing sensitive information. Non-technical objectives include things like determining what type of security measures should be used within the organization should be responsible for certain tasks. Non-technical objectives are important because they help businesses decide what type of security measures should be implemented and how those measures should be administered. What is a firewall? A firewall is a security device, computer hardware or software that can help protect your network by filtering traffic and blocking outsiders from gaining unauthorized access to the private data on your computer. A firewall acts as a gatekeeper. It monitors attempts to gain access to your operating system and blocks unwanted traffic or unrecognized sources. A firewall acts as a barrier or filter between your computer and another network, such as the internet. You could think of a firewall as a traffic controller. It helps to protect your network and information by managing your network traffic. This includes blocking unsolicited incoming network traffic and validating access by assessing network traffic for anything malicious like hackers and malware. There are software and hardware firewalls. Each format serves a different but important purpose. A hardware firewall is physical, like a broadband router stored between your network and gateway. A software firewall is internal, a program on your computer that works through port numbers and applications. What is a VPN? A VPN is a virtual private network. It gives you online privacy and anonymity by creating a private network from a public internet connection. VPNs mask your internet protocol, IP, address so your online actions are virtually untraceable. Most important, VPN services establish secure and encrypted connections to provide greater privacy than even a secured Wi-Fi hotspot. Why do you need a VPN? Surfing the web or transacting on an unsecured Wi-Fi network means you could be exposing your private information and browsing habits. That's why a VPN should be a must for anyone concerned about their online security and privacy. How does a VPN protect your IP address and privacy? VPNs essentially create a data tunnel between your local network and an exit node in another location, which could be thousands of miles away, making it seem as if you're in another place. VPNs use encryption to scramble data when it's sent over a Wi-Fi network. Encryption makes the data unreadable. Data security is especially important when using a public Wi-Fi network, because it prevents anyone else on the network from eavesdropping on your internet activity. What are the types of cybersecurity? Application security. The use of both software and hardware to ensure that applications are protected from external threats, even when in development. Applications require constant updates to stay up to date with any potential threats. Bugs and loopholes can be exploited to devastating effect. Information security. InfoSec refers to protecting your data or the data belonging to clients, whether stored or in transit. It involves protecting data in any form, digital or otherwise, from unrestricted access, manipulation, destruction, or disclosure/distribution. In short, data availability, privacy, and confidentiality. Operational security. These are the processes involved when dealing with data security. Handling, access permissions, networking, data transmission, and data storage. Network security. This all the processes involved in ensuring that the network is protected from unauthorized access and external intrusions. A secure networking infrastructure ensures that the internal network, intranet, remains uncompromised. Endpoint security. While remote access is a necessary component of workflows and business models nowadays, endpoint security ensures that it does not become a liability. Endpoint devices are easier targets, especially if the users are not sensitized to the risks and necessary cautionary steps. Identity management. Issuing rights and system access needs to be a well-documented and closely monitored process. At all times, all user access levels should be monitored and logged, with two-step security measures employed to prevent impersonator access. Disaster recovery/BCP. Business continuity plans, BCPs, are policies that stipulate the course of action in the event of an attack and or loss of data. This includes setting up off-premises sites for regular backups and to reduce the impact of attacks on business continuity. End-user education. The strength of a robust cybersecurity system is only as strong as the weakest entry point. Users must be educated on cybersecurity best practices like regular password change, two-factor authentication, and using VPNs when connecting remotely. Infrastructure security. This covers the physical aspects of computer infrastructure like a well-regulated power delivery system, good physical security, fire extinguishers, and the like. Cloud security. Cloud services are being incorporated into more business models and as such, need to be well configured to prevent any successful attacks. Difference between vulnerability assessment and penetration testing. Vulnerability assessment identifies vulnerabilities in a network. The technique is used to estimate how susceptible the network is to different vulnerabilities. Vulnerability assessment involves the use of automated network security scanning tools. Penetration testing, identifying vulnerabilities in a particular network and attempting to exploit them to penetrate the system. The purpose of penetration testing is to determine whether a detected vulnerability is genuine. If a pen tester manages to exploit a potentially vulnerable spot, he or she considers it genuine and reflects it in the report. Common types of cybersecurity attacks? Ransomware is a type of malware that denies legitimate users access to their system and requires a payment, or ransom, to regain access. A ransomware attack is designed to exploit system vulnerabilities and access the network. Once a system is infected, ransomware allows hackers to either block access to the hard drive or encrypt files. In ransomware attacks, adversaries usually demand payment through untraceable cryptocurrency. Unfortunately, in many ransomware attack cases, the user is not able to regain access, even after the ransom is paid. Malware or malicious software is any program or code that is created with the intent to do harm to a computer, network or server. Malware is the most common type of cyber attack, mostly because this term encompasses many subsets such as ransomware, trojans, spyware, viruses, worms, keyloggers, bots, cryptojacking, and any other type of attack that leverages software in a malicious way. DOS and DDoS attacks. A denial of service, DOS, attack is a malicious, targeted attack that floods a network with false requests to disrupt business operations. In a DOS attack, users are unable to perform routine and necessary tasks, such as accessing email, websites, online accounts, or other resources that are operated by a compromised computer or network. While most DOS attacks do not result in lost data and are typically resolved without paying a ransom, they cost the organization time, money, and other resources in order to restore critical business operations. The difference between DOS and distributed denial of service DDoS attacks has to do with the origin of the attack. DOS attacks originate from just one system while DDoS attacks are launched from multiple systems. DDoS attacks are faster and harder to block than DOS attacks because multiple systems must be identified and neutralized to halt the attack. Phishing is a type of cyber attack that uses email, SMS, phone, social media, and social engineering techniques to entice a victim to share sensitive information such as passwords or account numbers or to download a malicious file that will install viruses on their computer or phone. Password attack. Password attacks or any cyber attack where a hacker attempts to steal a user's password are one of the leading causes of both corporate and personal data breaches. Password attacks are on the rise because they are an effective means for gaining access to a network or account. Since many users do not set strong passwords, reuse existing passwords across multiple sites or fail to regularly change their password, hackers can exploit these weaknesses. What is brute force? A brute force attack is a hacking method that uses trial and error to crack passwords, login credentials, and encryption keys. It is a simple yet reliable tactic for gaining unauthorized access to individual accounts and organization systems and networks. The hacker tries multiple usernames and passwords, often using a computer to test a wide range of combinations, until they find the correct login information. Different types of brute force attacks are simple brute force attacks, dictionary attacks, hybrid brute force attacks, reverse brute force attacks, and credential stuffing. Simple brute force attacks. A simple brute force attack occurs when a hacker attempts to guess a user's login credentials manually without using any software. This is typically through standard password combinations or personal identification number (PIN) codes. Dictionary attacks. A dictionary attack is a basic form of brute force hacking in which the attacker selects a target, then tests possible passwords against that individual's username. The attack method itself is not technically considered a brute force attack, but it can play an important role in a bad actor's password cracking process. Hybrid brute force attacks. A hybrid brute force attack is when a hacker combines a dictionary attack method with a simple brute force attack. It begins with the hacker knowing a username, then carrying out a dictionary attack and simple brute force methods to discover an account login combination. Reverse brute force attacks. A reverse brute force attack sees an attacker begin the process with a known password, which is typically discovered through a network breach. They use that password to search for a matching login credential using lists of millions of usernames. Credential stuffing. Credential stuffing preys on users' weak password etiquettes. Attackers collect username and password combinations they have stolen, which they then test on other websites to see if they can gain access to additional user accounts. This approach is successful if people use the same username and password combination or reuse passwords for various accounts and social media profiles. What is two-factor authentication? Two-factor authentication, 2FA, is an extra step added to the login process, such as a code sent to your phone or a fingerprint scan, that helps verify your identity and prevent cybercriminals from accessing your personal information. 2FA offers an extra level of security that cyber thieves can't easily access. Different types of 2FA consist of hardware tokens, SMS and voice 2FA, software tokens for 2FA, push notifications for 2FA, biometrics, and location. How can you avoid a brute force attack? You can detect them by looking into your Apache access log or Linux log files. The attack will leave a series of unsuccessful login attempts. There are many methods to stop or prevent brute force attacks. The most obvious is a strong password, but others also include: limit failed login attempts, make the root user inaccessible via SSH by editing the SSHD config file, don't use a default port, edit the port line in your SSHD config file, use CAPTCHA, limit logins to a specified IP address or range, unique login URLs, monitor server logs. Thank you for watching this video. We provide hands-on training with labs, homework, group projects. Prepare you for the certification. Provide real projects. Internship opportunities. Support you in Resume, LinkedIn. Staffing support. Provide tech references. In-person, online class. Class retake options and more. Call us at 847-350-9034 for your free career consultation meeting. Please do not forget to like, share, and subscribe to our channel for the latest videos.